Gabe says, what's the differential equation? Which is this really good question for the course, differential equations. So, first, let's break that down. It's two words, differential equation, right? So there's a D part and an E part. What does the equation part of that mean to you?
Equal sign.
Yeah. There's an equal sign in it somewhere. Good. What does a differential mean?
It means it can be differentiated.
No. Nice. Good try, though.
There's a function who is
So not
derivative of another function.
Yeah.
Yeah.
Kind of.
Ish.
Ish.
You would assume there's a y, at least a y prime in there.
Good.
Yeah.
Not, it could be differentiated, but it has been differentiated. So there's some kind of, one of these guys maybe in there? Right, so basically, it's an equation, and it's got derivatives in it. Cool. This part makes it what's called ordinary. What's the other kind of derivative that you had available?
Partial.
Yeah, there were these guys, right? In Calc 3? That would be partial. So if I say a partial differential equation, you're going to say, I don't know how to do that. Get away from me.
Cool.
Cool? So this, mega hard. Not really mega hard, but we're not doing that in this course.
But possible.
Keep in mind, however, that the whole differential equations rabbit hole is a really deep one. So you can definitely trip and fall into this sucker all the way. It doesn't have a bottom. This is a ways further down than we're going to go, and this is a particularly wild and deep rabbit hole. But we're going to stick to here, ordinary differential equations. And the first and easiest of those no, we're not doing words like that yet. The first and easiest of those is something that happens all the time in life, which is the rate at which a population changes is proportional to the population. Right? What do you expect this to be?
Positive? Increasing? Well, it depends where you are.
Yeah. But I think you might expect this to be exponential growth, right? So that's the definition of exponential growth.
There's this kind of question there. I don't know what kind of answer you
Yeah, no worries.
Like, what is this?
So, my expectation is that this draws up in your mind exponential growth. And that is one of kind of a whole set of problems called population models. And exponential growth is the dumbest population model. And I don't mean that in that it's a bad idea to do it. I just mean that's the I tried something. This was something. This is the first and easiest thing to try. You guys cool with that? Okay. I think I have a couple other examples I know. There's one near and dear to your heart, which is P double prime is minus 9.8.
Hooray! Motion.
What's this one? Yeah, this would be acceleration due to gravity. And maybe this one. The rate of change of temperature is proportional to the difference between the temperature you are and the temperature of your surroundings.
Is that
Newton's.
Good. That's Newton's law of cooling. Which I'm hereafter going to call Newton's cooling. So, there's one other word I need you to know here, which is order. So does everybody first believe that these are all differential equations?
Yes.
Why are they differential equations?
There are equals differentials in it.
Because there's equals and primes. Are these partial or ordinary?
Ordinary.
Okay. So they're ordinary differential equations. You guys all with that? Okay. The next word I need is order. So the order of a differential equation is going to be at least kind of related to how hard it is to solve. But basically it's like the degree of a polynomial. You guys kind of with me on that? So what am I going to be counting to get order?
The
Plus fees.
amount of,
Yeah, primes. So this guy
first order.
is first order. And we're going to have a whole mess of words as we go through this. So one of the tricks of differential equations is that the very first thing you should learn to do is just spit out all the words. So right now, what I know about this guy here is that it's a first order differential equation. I am later going to add that this is a first order linear differential equation with constant coefficients. And those sets of words, right? I'm going to give you a whole mess of words. There's going to be probably 15 words, and some of the names are going to be 10, 12 words long. But once you know those things, if you just say it, there's always a technique that goes right with it. So all you got to do is figure out which kind of beast it is, and then apply the technique that goes to that beast. You guys cool with this? This one is particularly easy. I'll show you this one in just a minute. How about the p double prime is minus 9.8?
Second order.
Good. That one's second order. And this Newton's cooling guy
He's also
is also
first order.
first order. Okay. So what if I had something like y double prime is y prime?
The highest order would win, so it would be second order.
Perfect. Highest order wins, that's second order. You guys all good with these? So to recap, the words that I want you to know are partial, ordinary, differential, equation, and how to figure out order.
Why do we need to know partial? I thought we were like canceling that one out.
Yeah, so the reason you need to know partial is that's a partial differential equation. I don't know how to solve that yet.
Makes sense.
Right, so some of this is going to be, okay, I'm going to label this beast, that's a solution set I know already, that's one I don't know, or that's one Joe said was really hard or not possible. Right, so there are going to be a couple that were like, okay, here I come up with a list of words, and Joe said not to do those.
So would that be in like, this is like 2-dimensional and that's like 3-dimensional?
Oh, as far as the partial goes?
Yeah.
Yeah, so that's basically the problem, right? So these are kind of two-dimensional type objects, right? There's some kind of time or position variable, and then there's this response thing, right? So like in all of these, really, you're thinking of time as your independent variable, and then in this one, populations you're dependent. In this one, positions you're dependent, and in this one, it's temperature, right? So these are all really kind of a two-dimensional case. If you had something with a partial, it's going to be at least 3-dimensional, and then things start to get a little wacky. You guys all good with that? They're not impossible; they're just harder. Cool.